All right, good morning, everyone. Welcome February 24th. I'm glad you're back with us. We got a good lineup. So we're just going to do a couple things this morning. Our first block of presentations are going to be involved with tools, technology, and monitoring. We're going to dive a little bit deeper into the practitioner and specifics on those issues. And then this afternoon, we're going to get into a little more in depth on monitoring and research. So again, we're going to have about an hour open for lunch. We're going to have breakout rooms for you all to connect if you want. Again, put in the chat box if you guys need a room, and we're happy to facilitate that and get that set up for you. So this morning, let's just start off with a couple fun things. Let's do a couple polls. So first, here's a little fun one. What's your mood? If your mood was a color, what would you be? Green, blue, violet, black, red? Anybody angry out there this morning? So show us what your mood is this morning. All right. We're about 85%. We're almost there. All right, we're going to call it. Here we go. So great. Everybody's looking green and calm. Few people excited, few people very happy. Couple tense and nervous people. Good to hear that nobody is angry. So very, very good to hear. Okay, so let's do one more. What is your favorite river activity? Let us know what you do out there on rivers. How do you play? How do you relax? How do you do on rivers? All right. Got a lot. Oh, we hit in every category, at least what we have. Sorry if we didn't capture everybody's river activity out there. Okay, 84%. Okay, we'll share those results. There it is. Looks like we are tying with fishing and kayaking, close second by rafting and photography. Supping, canoeing, skipping rocks. We thought about putting skinny dipping on there, but we decided not to. So, all right. Well, thanks for joining in on those activities. Just wanted to break the ice this morning a little bit. I want to give props to our sponsors who enabled us to have this conference, put this conference on, gather all the resources that you're hearing today. So again, thank you to all the sponsors that made our conference happen, and their generosity and their support. We sincerely thank you for it. Without further ado, I think we'll get started on our sessions for this morning. So this morning, we're going to kick it off with Chris Sanderson from Tetra Tech. We're going to talk about applied remote sensing in the middle Rio Grande, and then the presenters will be with us afterwards on their presentations to do some Q&A. So thanks, Chris.
Hi, everybody. Thanks for attending my talk today. My name is Chris Sanderson, and I'm an ecologist at Tetra Tech. I've been working in various settings throughout the arid Southwest, including MRG, for about 10 years now, and that includes a lot of vegetation and species monitoring, including flycatcher surveys. And I'm just giving some of that background today just because I want to emphasize the applied aspect of these remote sensing studies that are really designed for use by management entities and for ecologists like myself who are interested in GIS and also love being out in the field. So I'll provide a introduction. There we go. To just the idea and some general concepts related to landscape scale monitoring. a lot of this is dealing with identifying and evaluating, quantifying patterns that may not be apparent during field surveys. A lot of these patterns are things we can't keep pace with. The rate of land use change or defoliation by Tamarisk leaf beetle. So the Tamarisk leaf beetle itself has been in the MRG since around 2012. It's known to negatively impact flycatcher breeding and nesting habitat. Of course, it can create an ecological trap for nesting flycatchers. A lot of problems with the Tamarisk leaf beetle that I'm sure folks are well aware of. So the use of these tools can be used to track defoliation and quantify it. And the two major vegetation indices that we use to track that change is the Normalized Difference Vegetation Index. And this will capture defoliation and mortality via decreasing photosynthetic activity. And that also relates to reduction in biomass, and really, as in this case, we're looking at impacts to tamarisk by the Tamarisk leaf beetle. So that's our first study that we did for the Army Corps of Engineers. And the second use case I'm going to present today was a really cool project we did for the Sierra Soil and Water Conservation District, the Tiffany Fire down in Socorro County. We use the normalized burn ratio, which is a commonly used metric to evaluate burn impacts. And these can provide really good time-sensitive information to land managers. We use that to inform some of our planning and restoration ecology decisions down there. So these vegetation indices are really just used to construct a temporal trajectory. We can isolate areas for further analysis, and really the idea here is to exploit the reflectance curve of vegetation or soil, whatever you're looking at. So where the rubber really hits the road is in these arid riparian systems. NDVI has been found to correlate with canopy cover of riparian vegetation, and it's also strongly influenced by changes in groundwater conditions and availability. And similarly, the normalized burn ratio has a relationship with the near infrared and on the electromagnetic spectrum there. It's represented in that graphic on the bottom right. So the design of these studies is really important. I have a graphic here that shows the difference between Sentinel Pixels versus Landsat. Sentinel is 3 times higher spatial resolution as compared to Landsat. And it also has a really good temporal resolution in terms of when the satellite is revisiting these areas. So you can get a Sentinel scene every 10 days. So that comparison with Landsat is there just because the Sentinel grid is really appropriate for these riparian settings where we can get a finer scale idea of what's happening out there. And Sentinel-2, it's a European Earth observation mission. It's conducted by the European Space Agency, but it's available through the USGS. And that gets into some of the software we use for this. I won't spend too much time here, but there's a constellation of software out there, and there's a lot of different tools to do the same job. I will give a shout out to open source GIS, QGIS in particular, that has some excellent tools for both downloading and doing image analysis for multispectral raster data. So our first use case here is the Tamarisk leaf beetle study. And here we found there was a real need to evaluate and understand the ecosystem level changes and consequences of tamarisk as a biocontrol agent on a landscape scale. These successive defoliation or foliation events are difficult to track, as identified in the first couple slides there. So in this case, we looked at 25 river miles and over 8,000 acres of bosque habitat. We used 2016 Hinkenomart vegetation mapping to mask out and exclude other vegetation and just look at Tamarisk dominated stands. And we conducted a difference of the NDVI over about 30 different Sentinel scenes to construct that temporal trajectory and understand what was happening at these sites. So the raster on the right there with the scale bar is one scene from late July of 2016, just showing what an NDVI raster looks like. That scene is the entire floodplain without the Tamarisk mask. In this next scene, we have actually masked the Tamarisk, and this is a result of putting together those 30 different scenes into a product that tracks a longer scale, 3 years of Sentinel data for this area. So for the Tamarisk stands, we saw about a 6% decline in NDVI activity, whereas the non-Tamarisk stands saw a 3.3% increase in NDVI. We classed those out in 3 different classes using a zonal analysis just to arrive at a simple decline, no change, or increase in NDVI. And when we did an overlay onto wiffle nest sites, we found that some wiffle nest sites were impacted through this decline in NDVI values. And our assumption there was those nest sites were negatively impacted. Now, some compounding factors for some of these issues is just the nature of the patchiness and refoliation in one growing season. We saw areas that were defoliated where other areas weren't, so there is just a lot of complexity there. I think precipitation does correlate with some of these NDVI return values. And then on the bottom two graphs there, the 2017 and 2018, we were working with some folks from NAU, and the horizontal bars there are defoliation events that simply didn't track with the reach scale analysis we were doing. I think that was mostly due just to the localized impact of the Beetle on this system. But again, we did demonstrate that we can identify imperiled wiffle nest sites. So yeah, the next use case here is down in Socorro County again. This is the work we did for the Sierra Soil and Water Conservation District. So the Tiffany Fire, for folks who don't know about it, was a really big fire event. It was lightning-caused fire that burned over 9,000 acres, burned a lot of tamarisk. This was a tamarisk-infested site. There was a significant loss of cuckoo habitat, and it was a really cool project for us at Tetra Tech because we were able to wield all of our team's skills to perform a suite of analyses from the ecological side, and then getting into the hydraulics and hydrology. So really getting into this eco-hydrological framework to really understand what was happening at this site and understand the challenges at this site. So at the lower right there is the Sentinel scene prior to the fire on June 21st, 2017. And then about a month later, in July, that is a post-fire scene. So that just demonstrates the time-sensitive nature of the system. We can get in there every 10 days, assuming there's not a lot of cloud cover. We can get in there and get a good picture of what's happening. So those are the 2 scenes we selected to perform the difference NBR raster analysis on this. So these are the results. So the frequency chart here shows the distribution of NBR difference in NBR values. So about 30% of the site was unburned, and then about almost 50% experienced a moderate high to high severity burn. And I went out there and checked out the accuracy of these of GIS results, and they were pretty accurate. And this informed our planning for restoration, where we took the results of the burn vegetation, and I was able to identify what areas had burned, whereas what areas did not burn. And this helped us identify both some high value mixed and native habitats that were unburned, and also areas of burned tamarisk that needed to be treated differently versus areas of unburned tamarisk, for example. So this fed into an overall restoration model where we took LiDAR and we established a groundwater model with 4 classes. And these classes that we had were broadly associated with site potential on an eco-hydrological spectrum of Masic to xeric, where the green is a comparatively wetter site to the yellows and oranges you see. We further used, we developed a height above river model, which uses the height of both the low flow channel and the Rio Grande itself, the water elevation in relation to the surrounding landscape. And what we used that for was for more detailed level site planning that you'll see in the next slide here. So here's where all those elements came together. So this site has unburned mixed vegetation we identified that we could build on in a restoration context. So use some of that to develop a nice patch and mosaic in a restoration type scenario. And then we also used the depth to water and height above river model to identify areas that were appropriate for to restore a wetland versus areas that you would want xeric shrubs or xeric grasses. So the whole spectrum is represented at this site. And similarly, we took this other site, this is known as the Condo Site. It's a really cool site. It's previously a wetland and riparian area. It did have flycatcher breeding and nesting in the early 2000s. It's underwent a lot of drying just as a result of persistent drought and some changes in the channel bed elevation of the river. So in this site here, it was more driven by the depth to water and height above river models. But we were able to introduce different restoration concepts, big wetland, big flow through channel, backwater features on this really interesting and compelling site. And the last site here is at the southernmost end of the Tiffany project area, right around River Mile 63. Here we have this gorgeous mosaic that's a result of the application of mostly the depth to water and height above river model, where I've identified these different restoration classes going from wetland all the way into the xeric areas again. And this site has a lot of potential just based on its optimal depth to water values and a lot of existing vegetation and ongoing regeneration dynamics occurring at this site. It's a great site. So what now, these tools can be leveraged in a lot of ways. I've just shown a couple different case studies here. We can identify, using these tools, we can identify opportunities and risks for restoration on a landscape scale. And these also allow a more cohesive approach to restoration projects across a landscape without having to rely on inconsistent data over time. The remote sensing really allows for a consistent approach to understanding these systems. And that's really just repeatability comes to mind. I think the Army Corps of Engineers. I'd also like to thank the Sierra Soil and Water Conservation District and Also, some other authors on the TLB study over at USGS, NAU, and CSU. So that's it, folks. Thank you.
Chris, thanks so much for the presentation. We do have Chris Sanderson with us with Tetra Tech for questions. I want to remind everyone to just hover on your toolbar at the bottom, the chat box, and enter any questions that you have for Chris into the chat box. This goes for not only Chris's presentation, but all presentations for today. So, Chris, first question, was the NBR data derived from Sentinel-2 imagery, or did you need to do some custom flight for that data?
It's all the same data. So it's all Sentinel data, multispectral data product, and it's atmospherically corrected, and that's the key for providing repeated comparable analysis.
Next question, how are the costs and time to delivery of images for Sentinel data?
Yeah, I should have mentioned in my presentation, it's Sentinel is available free from the USGS. So, the time and money goes into the processing of those raster data sets.
Okay. Chris, I have a question. What is the long-term trajectory for this project, maybe this type of project? Will you continually add, data to this, monitor it with additional aerial imagery? What's your time frame for this?
I think it's certainly something we'd like to carry forward, especially considering the flycatcher in the Middle Rio Grande. This is a hotspot for the flycatcher in terms of, compared to other areas in the U.S. Southwest and territories and nesting. So with the ongoing, disturbance of the TLB of Diarrhobda, and this needs to be better understood in terms of some of the nesting dynamics and what areas, even not necessarily impacted by TLB, are undergoing decline either through drought or just through climax condition for that riparian vegetation.
Okay. In your one slide, you referenced the decline of Tamarisk and I think the decline of native. Is that just vegetative decline? Is that just pure greenness? What is the decline that's noted there?
Yeah, that's a general decline in photosynthetic activity, which is basically what NDVI measures.
Okay.
Through the looking at that electromagnetic spectrum. But and the key thing there is to develop some classes. So those 3 classes give us a general framework on what areas to look at further in the field.
Great.
It's real interesting. I just wanted to note, and it's not in my presentation, that that 10-meter grid is really important because especially in like south of our project area, there are flycatchers nesting on these very, very narrow patches of riparian vegetation that are 20 meters or so in width. And I might be a little wrong on the exact width, but they're very narrow little pockets.
Okay. Well, Chris, thanks so much for being with us. It looks like that's all the questions. We're going to keep this going. Thanks so much for your information.
Very cool. Thank you. Thank you.
Yeah, thanks. I wanted to remind everyone, looks like Jim Hatton wanted to put a plug in there that looks like Google Earth Engine has data as well, data that can be ready to go. Jim, of course, is a foremost expert modeler for some of this work as well. So just want to put that plug in there. So Chris, thanks so much. And if you have any other questions, Chris will be around for a little while, maybe.
Yeah, I'll be around. And I tried to get a Google Earth license, Jim, but they wouldn't give one to me. Maybe we can talk.
Okay. All right. Well, next up, I'd like to welcome Pam Nagler with the U.S. Geological Survey. Pam is going to present on a riparian ecosystem data explorer for monitoring the lower Colorado River. It's an integrated and dynamic web-based delivery of actionable information. Pam, thanks so much for being with us, and we'll go ahead with her presentation and a Q&A afterwards.
Hi, I'm going to tell you about our Riparian Ecosystem Data Explorer for monitoring the lower Colorado River. It's called the Integrated and Dynamic Web-Based Delivery of Actionable Information. I'm Pamela Nagler, and my colleagues that are putting this together with me at the University of Arizona are Armando and Kamel. So I'll give you a little background. Intensification of drought across the Colorado River Basin is causing ecosystem stress and catastrophic transformations that result in increasing challenges for resource management. Over the past 2 decades, the riparian plant species on the Colorado River have declined drastically, suggesting further deterioration of biodiversity, wildlife habitat, and key ecosystem services. Researchers from the USGS, myself, and the University of Arizona, Armando and Kamel, have built an interactive, searchable Lower Colorado River Data Explorer for the purpose of allowing users to monitor the riparian ecosystem health and changes due to defoliation events from the Tamarisk beetle. Some of the pressures that we have here are not just due to Tamarisk beetle, but also invasive species in general, and how that affects endangered wildlife, fire, and some of these smoke and clearing and how it's affecting the atmosphere. We have diverted water sources, lack of overbank flooding and backwaters, and other land clearing, and change in precipitation and seasonal pattern of rainfall. So in many places of the American Southwest, they've undergone these environmental changes that have led to myriad restoration techniques. A lot of effort over the last 2 decades to restore this riparian vegetation has happened across this dryland ecosystem. In this specific case study, we're going to talk about the riparian reaches in the delta of the Colorado River, which have undergone reductions in green vegetation from human-induced activities that have caused water stress to plants. And the reduction is due to the diversion of surface water at the international border, groundwater losses, land clearing, fire, and minimally from changing precipitation patterns. As we know, riparian zones provide critical habitat to more than 90% of wildlife species and are very important breeding grounds and serve as avian flyways. But these unique ecosystems occupy less than 2% of this arid southwestern landscape. Riparian restoration is on the rise as our riparian areas experience deterioration and declining health, and accurate consumptive water use estimates, including transpiration rates from certain riparian species and ET for wider areas at the river reach level, are needed to begin these active restoration projects. The importance of ET is that water is the primary environmental driver of plant productivity and an important metric of the efficiency of water use. ET is a key component in the hydrological cycle and is an indicator of the resilience and resistance of vegetation under drought. The amount of vegetation is directly related to important information about how much water is lost in ET from riparian systems. And in the delta, which is a very dry river area, about 90% of the rainfall is transpired. ET knowledge helps the managers budget water for both human and natural habitat, as well as for other ecosystem services provided by flows. Accurately measured riparian ET has rarely been included for water budgets because these riparian woodlands are not as accessible in terms of ET estimates as agricultural estimates, which have often been used in place of riparian woodland estimates. What we're trying to do is produce data for the end user, and this could be linked through different areas of USGS research like landscape change, phenology, consumptive use and water availability, groundwater modeling, wildlife habitat, avian use modeling. And we wanted to provide a record of the last 2 decades of vegetation greenness for these riparian zones and their water use so that we could look at the sustainability or the riparian health along this portion of the lower Colorado River in the delta. We hope our methods and results provide information for decision makers tasked with using water, for restoring natural environments, and for planning a future with healthy riparian ecosystems. One way of looking at this is we have alfalfa as our highest amount of water use, or grass. We call that potential ET. And it's usually in the area of about 2,000 millimeters a year. Crops use almost that amount, a little less. And riparian vegetation has varied from about 450 to 1,150 millimeters a year. Cottonwood trees are at the high end of that. And between the delta and the bit of the lower Colorado River below Hoover, we see that this range in ET is between, it started out in the year 2000 at about 1,160 millimeters, and it's down to 777 millimeters over a 20-year period. And in the delta, it dropped from 1130 to 654 over that 20-year time period. So we're using remote sensing to monitor environmental changes. We have sort of a multi-sensor data product that we pull in from sat flow on the ground to eddy covariance tower and weather station information on the ground. And then we have several methods of estimating ET. There's thermal and energy balance methods by my colleague Gabriel Sine, who works for USGS in Fort Collins. And I have an optical vegetation index method. And we're applying this to riparian zones. We're using NASA imagery. We have Landsat, MODIS, and VIIRS. We pulled in the European Sentinel data as well in some areas to get at this narrow riparian corridor. Remote sensing data and their techniques are able to provide an alternative to ground information and quickly and cheaply track vegetation changes that aid in the management of these riparian systems. What we did is we used both Landsat and MODIS and did it over 20 years, and we derived vegetation index as an estimate that goes into our algorithm to look at ET. And as we track that for the full year, we took the area under the curve of the vegetation index to estimate what we're calling a phenology assessment metric. And that area under the curve gives us an annualized ET. Research technical problems and science contributions are that we have provided for science improvements. We applied an ET method that used MODIS at the Landsat resolution. This was able to bridge an amplitude gap for vegetation index across the 3 Landsat sensors in the last 20 years. It would be Landsat 5, 7, and 8. And we looked at evaluating these phenology shifts with this annualized ET data, or we call it PAM, to evaluate the total annual water use. We also employed new analytical methods and statistical tools for evaluating time series vegetation index and water use trends. One of the things that we did was to address 2 remote sensing application problems. We looked at the challenges of differences in spatial resolution when applied to detecting these land cover changes in riparian areas, and we used multi-sensor and VI amplitude shifts in our time series data to look at changes in the Landsat sensors. So between TM5 and ETM plus and OLI. So we've ended up doing some gap filling. NDVI is shown here. You see it's a much higher amplitude than EVI, which is the best sensor to use, best vegetation index to use in these drylands. What we've done is mapped greenness, phenology, and water use. One of the things I'd mentioned was that NDVI saturates at the high end and doesn't produces an increased amplitude. So EVI performs throughout the entire range, and this is a better dynamic range, so that we are now using EVI in our ET equation instead of NDVI or even the scaled NDVI. And one of the things we've done is provide the phenology year after year. This on the top right shows January to December. These are, the black is the 20-year annual curve, and you can see how in the recent 10 years vegetation has really dropped in these riparian zones, almost looking near bare soil. Now in Mexico, where you have restoration sites, this phenology curve on the lower graph is much tighter. And so, except for this last year in 2019 and 2020, we have some updated data. Most of these years were higher and tighter, showing that the phenology held throughout the whole year in restoration zones for active restoration of native trees. This is a plot of water use ET over the last 10 years. The blue lines indicate where we had changes before pulse flow in 2014 and after is shown in the red line. So we wanted to see if surface flow had changed at all, any of the vegetation response. So here's what we built, a Lower Colorado River Data Explorer. It's an online platform to interactively visualize and analyze this remote sensing time series, these NASA products, in support of riparian studies.
Hi, folks. We're working on the sound. We'll be back with you here in just a sec.
All right, folks, gonna start it back up here. It looks like about a minute of audio is just missing for some reason, technical difficulties in recording. So you can just ask Pam directly about what she talked here momentarily.
This is a schematic of how the data is standardized and filtered and how we do the long-term averaging using continuity equations and gap filling so that we have a clean trend data set so we can look at these changes over time, which in this lower right-hand corner you can see are declining over 20 years. As a web application, this Data Explorer provides integrated data delivery and decision support. It was developed with a modular design so it can accept new data and models as they are developed, and it is responsive to stakeholder needs for updated information. In order for this to work and evolve and become a fully functional and operational service for scientists, land and water and cultural and resource managers, and the general public and stakeholders, our Data Explorer does four things. It has data storage requirements, it has processing resources, it has a web and tool developer time that's needed, and long-term host or a location. The current system and infrastructure is versatile and modular, so it can be ported to another location and moved to another platform such as EarthMap or GEE. So I want to quickly just show some results. Here we show Landsat and MODIS in black and red. We show that with our data processing, we've been able to modify our ET equation here on the right side to be almost identical at these two spatial scales. Here we show year upon year with some changes pre-pulse in this upper orange dotted line, and black is the mean of 20 years, and this tinier orange dashed line is for after the pulse flow. And so that we see that before the pulse flow, our data was quite high and riparian health was good. And then it dropped over time because of these added years in the natural part, not the restored part of the riparian reaches. These have just been plummeting in the last few years, and that has had an effect on the post-pulse flow years of the last 5 years. So the surface flow really didn't help out too much in terms of riparian ecosystem health. Where we do see it helping is where we have restoration areas. And we have the transboundary area, we have the parts in Mexico where it's just declining, but the restoration is holding relatively tight up until the last year or two when we've had added days of hot temperatures and little precip. Another way to show this is to look at the annualized water use. We did on the left side is Landsat, on the right side is MODIS. We could just zoom in and talk about how we've tracked this reach by reach. This last column shows all reaches of the entire delta, and you can see this entirely declining trend. Blue is before the pulse flow, red is after the pulse flow. If you look at the percent change from year to year, you can show that there were areas of greening, like in 2009 to 2010. You have years of losses, a couple of years in a row, following that line of greening. And then when you graph it out, you can see that pretty much all of the vegetation, going by vegetation health or greenness from the EVI, is below zero. So it's all decline. The clear color indicates all reaches. The darker shows the largest range. So reach 2 had the largest range. We can see this in terms of line plots, the rate of change in greenness. We had this peak here in 2009 and 10, but other than that, everything is below zero pretty much. And after the pulse flow, we did see some greening, and that's this darker green box here on the upper right, compared to the whole 20-year trend. So the pulse flow did help boost greenness just a little bit. We show that also in our water use estimate. So that is ET here. We made maps of our 20-year differences using scaled NDVI and also a water use on the right side. And this shouldn't say difference in NDVI, it should say a difference in NDVI star. This is the scaled NDVI that helps with illumination differences scene to scene. We can see that most areas show these giant decreases into the dark brown. And one area of green up here is in reach 4 where we do see restoration. Here's the same thing except for water use. That was over 20 years. Now we're showing over the 5-year period. So it's less dark brown and more in the medium brown. So the pulse flow did help somewhat in terms of instead of having drastic decreases, it helped boost it a little bit. And we have these same areas of greening in the restoration zones for water use, as well as in vegetation. So our major findings are that greenness and ET drastically declined by 34% and 38% of water use. But since the pulse flow, these metrics declined a little bit less, 20 and 23%. One of the things I want to point out is over here that in a few reaches, we saw declines as high as 42 to 44%, with ET as high as 2 millimeters a day. That's a giant loss in water use based on a loss in riparian health. The pulse flow did add enough subsequent water to help the restoration sites and revive riparian health. And the benefit of this water was only evident for 1 or 2 years. Overall, we see a decline of riparian vegetation from 1,130 millimeters in 2000 down to 654 in 2020, a decline of 38%. But restoration is on the rise, and our riparian areas experience deterioration and declining health. But accurate consumptive water use estimates, including transpiration rates for these riparian species and ET for the wider area, are needed to begin the active restoration projects. So we need to know what vegetation, what their rate of transpiration is, and what the water use is at the wider area. Our Data Explorer allows for the end user to search for trends and anomalies. The last thing I want to do is summarize the points for our Data Explorer. We have base data layers for the dryland riparian area Data Explorer, multi-source NASA imagery through data fusion techniques, Landsat, MODIS, VIIRS, etc. There are multiple data layers that should be considered in our Data Explorer, like vegetation index, land surface temperature, LAI, GPP, climate data, soils. A brief vision of how we have built the Data Explorer to look and function is that we have a base long-term average map of parameters related to climate and vegetation responses, the longer the better, climate and weather data, value-added climate parameters, soil moisture, ET, this kind of thing. Looking at anomaly maps that we've created that show how current status compares to the long-term or average of all the parameters. A tool that enables dynamic inspection and query of sites, areas, and regions. The tool should be smart to permit quick online inspection of the data. A projection or model tool that can project current status forward for a few weeks or seasonally and provide insights into the future of how the riparian ecosystem health metrics are progressing. The design of the Data Explorer should be the simpler the better. The closer to real, traceable data, the better. Some form of citizen science portal where citizens can provide localized data from across a large area with incentive, recognition, image of the month, something like this for acknowledgement. So that is all for the Data Explorer we've created for our riparian areas along the lower Colorado River. Thank you very much.
Okay, thanks so much, Pam. Looks like you've done a good job answering the questions in the chat box. We'll just take a quick minute for any other questions that we have.
I fell asleep in the break, sorry.
No problem. This Data Explorer
long.
is only, oh, sorry. This Data
I was
Explorer
just
is
saying it
only,
was super long time. So if you want to send questions, I can answer them in the chat.
okay. Looks like we have one in the chat for you if you want to answer it. I have a quick one on your takeaways slide, your second to last slide. You talked about, I think I heard you say that more information is needed on evapotranspiration. I'm paraphrasing that. Is that isolating specific native versus invasive plants and getting more evapotranspiration data on that?
Yeah, that was great that you picked up on that. So my next goal in life is to probably hand digitize from the imagery, but also from knowing what's going on the ground from people that have been out validating, to separate out primarily tamarisk, but separate that from arrowweed and mesquite. That's a little bit hard to do in the imagery. We just had a hyperspectral collection over the first two reaches in the Delta that could maybe work with separating brown litter from background soils. But the idea would be to be able to go in and hand draw those polygons around native versus non-native, and then quantify our ET estimates and our greenness from that.
Okay.
And I just want to say I was really thrilled at the order of the speakers, because the background and remote sensing was wonderfully presented prior to my talk. So thank you, Chris. I think it was Chris.
Yeah. Well, Pam, thanks so much. There are a couple questions in the chat box. I guess one quick one is the Data Explorer only available for the lower Colorado?
It's a good question. So we're uploading it for many, many different rivers, but depending on the end users, we're asking for like a coded password because our data with USGS, of course, has to be approved, and a data release and a DOI number given to the data itself. So as we're doing it like section by section of these different rivers, they will get a DOI number, and then we can give the interested parties the password to see. They can play around all over it and look at anomalies and track changes for your specific areas. But we have to get the data approved prior. So that's why it's password protected sort of at the moment.
All right. Pam, thank you so much for your information and your work. Appreciate being with us.
Thank you.
Okay, keeping it moving on. I'd like to welcome James Major from River Management Society. His presentation is how to use the National River Recreation Database to plan and execute research and management objectives. And I think James will be with us. So,
Well, hello, and welcome to my talk today. I want to thank RiversEdge West for hosting this conference and letting me speak today about how to use the National River Recreation Database to plan and execute research and management objectives. So going beyond the research aspect, going beyond the recreational aspect, and including research and monitoring trips as one of the things that we can do using this database. A little bit about me. My name is James Major. I'm the National Rivers Project Coordinator for the River Management Society. I'm excited to join this conference for the second time. First time I went as a grad student when it was held down in Phoenix at the Botanical Gardens. And I thought it was such a great conference, so I'm excited to be able to present it today. A little bit about RMS, if you're unfamiliar. Our mission is to support professionals who study, protect, and manage North America's rivers. We have over 400 members in 7 chapters across the United States and some in Canada. They're dedicated to river management. And some of these members include federal, state, and local agency employees, educators, researchers, nonprofit river stewardship and water trail organizations, individuals, and students through our River Studies and Leadership program at various colleges around the U.S. RMS has several different projects that we work on. We do river trainings for river managers dealing with a wide variety of issues, such as wild and scenic management, CRMP, Section 7 trainings, things like that. My side is on the National River Recreation Database, which is GIS-based. It's a geospatial portfolio of information on wild and scenic rivers, water trails, whitewater rivers, access points, and campgrounds within both the United States and in Canada, especially in rivers that are near the border, where you still need to have some access points and campgrounds, things like of that nature. So the NRRD is a good starting point for planning a trip. It's not where you go to comprehensively planning a trip, and I'll show you a little bit more about that when I do a little scenario about how you might use it in real life to plan a research trip. But it's a great place to start and has the resources you need to get you to the endpoint, to get you in the water. So our original project goals were to offer a high-level view of rivers across the nation using attributes important and familiar to fans of rivers and outdoor recreation, and how to direct visitors to a definitive detailed resource for experience to help plan their visit. And I think this can go beyond recreation and easily into the research and academia, as well as monitoring and restoration activities. Because as my background is in as a research assistant as an undergraduate in Oregon for fluvial geomorphologists studying gravel bar and doing structure for motion modeling using photography with drones and camera on pole and things like that. We had to plan multiple river trips to do that on the Rogue River and Sandy. And it can be a lot of work. So I'm hoping that this resource can help folks with some of the hurdles that can be in the way of a successful trip plan. So here, this is also showing at the top a little bit of our attribute table for flowable reaches, river access sites, and campgrounds. This shows just some of the data that we have in the NRRD. For instance, the flowable reaches here shows maybe 10 different categories or 10 different attributes, but the entire thing holds 26 different columns of data about the river that I'm happy to share with anyone that needs information about rivers. So we have almost 2,000 flowable reaches that we have in the United States and Canada that are cataloged, along with 14,500 river access points and over 700 campgrounds. So we don't just find the data and stick it in to our attribute table and then let it go live just whenever I find it on the internet. What we do is search for information and then send it off to be vetted by local partners. So for instance, currently we're working on wild and scenic BLM rivers that are managed by BLM. In fact, adding over 600 miles of wild and scenic rivers to the database just this year already. And so currently we're working on Oregon is the next state for BLM managed wild and scenic rivers. And what we'll do is collect all the data that we can from various sources on the internet, and then send that over to the state lead BLM, who will then disseminate that to regional offices where people on the ground have local knowledge of these rivers. They vet that information and send it back to us, back up through the chain of command. And then when I get it, then I add it to the database. So that way we keep it as authoritative as possible, up to date as possible as we check in with our partners as frequently as possible with such a large database. And that way you can feel pretty confident about what you're trying, about planning your trip. So we'd like to thank our major partners in this endeavor. And these are just some of the large ones. We have over 50 other partners, smaller partners, friends groups, you name it, other small organizations, state groups. So we're happy to have their support, cooperation. To get this data out to the public, we have nationalriversproject.com, which is our website and portal to all the information, or most of the information that we store in the database. And so I thought it would be good at this time to do a little tutorial to go through a scenario. So I'm going to switch which one we are showing and go to our website over here. So this is our home page where you can see we've got our wild and scenic rivers and water trails and whitewater rivers. And you can find a featured river that's near you if you're not looking for a specific river at a specific time. But we're going to say that we're a grad student looking to do research on how cottonwood trees planted 20 years ago within elk exclosures are faring in the wild and scenic section of the Rio Chama between El Vado Dam and the Sibique Reservoir. There are some access points that you could maybe hike down to the river in certain places, but that's not the most efficient way to do it. This study is most efficiently conducted by boat, putting in below the dam and floating down to the takeout. And this is pretty, I think, pretty common, at least in my experiences, of a way to get to remote areas to do some studies. You could go directly to the river that you're looking for. We're going to start off at a macro level and look at our entire map minus Alaska. You can see we've got those added rivers up there. You can see that a lot of our rivers and water trails are heavily focused along the East Coast and the Midwest. We've been doing a lot of work with partners over there and have finally started to really work with the partners in the West. Like I said, we're adding the BLM Wild and Scenic Rivers currently is the project, followed by the BLM Non-Wild and Scenic. So stay tuned in the West, and there'll be a lot more opportunity in the upcoming several months when these become online. We can see over to our right, we've got filters where we can filter our rivers by how difficult they are, whether they're wild and scenic, whitewater rivers, water trails, and then other amenities like if there's fishing or if you need camping or a boat ramp, near. where you're trying to do your research. Or so for us, we're going to go to the Rio Chama. And you see it predictively comes up as a search. And so we'll click on the Rio Chama and it will click us over, and we will, for the purposes of this, unselect it, take it out of the search bar. So we can see that this is a wild and scenic river and also has white water. So we need to know more about this river so we can figure out who we need to bring along on our research trip. If I'm studying trees but I've never rowed a boat, I'm going to need to find someone that can row a boat if there's white water of sufficient difficulty. So let's check it out and see what it says. All right, so we got two sections here. And this is a class 2, class 3, so intermediate. So I need to get someone that's rowed a boat before for our research trip. But the good news is for this section, I don't need a permit, which we know can be difficult to obtain, and the timing for a permit is important for our study, perhaps. This is managed by the U.S. Forest Service. We can also see where the management is. Then we can see where our access points are. So we want to do the entire river stretch between El Vado and the Cibecue Reservoir, or at least the nearest takeout to that location, because we have various sites all along the river where they planted cottonwood trees a couple of decades ago that we need to check on. So we check out put in, we want the top, and as we can see, it's a carry-in at the El Vado Ranch. It's actually right next to the river, easy carry-in, and some of the carry-in locations for our sites may even be primitive ramps where you could back a trailer in if you're daring, but if it's not a developed ramp, we keep it as carry-in so we don't get your hopes up. Does cost money to put in there. There are restrooms, which is nice, and you can park overnight. So we know we've got a place there. And we know we want to probably take out at the lower end. And we see that it is a boat ramp, so that'll be nice. We'll be able to just back it in and pack it on to the ramp, to the trailer. Parking is day use, so that's something we need to keep in mind for later to make sure that we can leave a shuttle vehicle there. There's no fee, that's nice, and they do have restrooms, which is always nice at the end of the trip. So in the middle, if we do decide, it's also day use, also carry in. So we're probably just going to go down to the ramp and contact the Forest Service to see about overnight parking. So now we need to look at the stretches themselves, see what we're dealing with. We've already looked at this one. We know we've got intermediate class 2. So let's look at the top. All right, so it's a class 1 and 2. So that's another thing you can take into consideration. If you don't have a more experienced boatman, you could take out at that first location and not get the class 2-3 rapids in the segment below. So that might be a consideration. Another big thing that we find out early on is that we need a permit. So now we need to know what office we're going to go through to get that permit. And hopefully we can get a special use permit, something like an admin permit, so we don't have to wait on a lottery. But it's something good to know at the beginning of the trip planning and research trip before we find out that we're not going to be able to do it this year, so we don't get a permit. And if we do get a permit, it's not at the right time for what we're looking at. So we need to look at more details so we can figure out what's going on. All right, so we can see our segment there. It gives a little bit about the landscape. As a river becomes a featured river, we like to add more detail. So quite a bit of these different segments have much more information about that particular river. But we can see that it's multi-day, so we need to make plans for several days of camping if we do get the permit. We can't have more than 16 people, so we can only have a small research group, which typically I wouldn't think would be a problem. But we can also see that now is the Taos field office is who we need to get in contact with. So that from there, you'll be able to click on our partner information and go, and then you'll be able to see what you can do about the permit. And so we also need to see a little bit more about the next section. So there's only a day float here, so we only add one more day to our trip. And then we can also get a hold of the Forest Service to see about the parking situation. And so we're well on our way to planning our trip. So that's a good thing. Let's go back to our here, and I'll wrap it up with what I want to show a little bit about with the National River Recreation Database. And I'd like to field any questions anybody might have. Thank you.
All right, James, thanks so much. Very cool. Anybody that's tried to put in for permits and figure out river systems, all the agencies, all the management, all the different logistics that go into it. Pretty cool. So want to remind everyone, if you have questions for our presenters, add them to the chat box. James, what are your data sources strictly the management agencies, or is there like an open source where rafters kind of feed in information like, hey, restroom here, bad parking here?
We definitely have on our website a form that you can fill out to provide information. So we would then take that data and vet it through local agencies or friends groups or people that are on the ground in that area, so that we get as up-to-date information as possible. We just like to really keep partnerships with local groups. It really helps our cause.
What is the progress or your intentions of filling out the Western Rivers section? Obviously we're that would be a great resource for people out here.
Yeah, we have we've worked with the agencies to get funding, and then as that comes along, that's typically how we decide where to go. So we've got a grant from the BLM to do the wild and scenic and the non-wild and scenic boatable reaches in the west, where most of the BLM land is. So I'm working through the states now to do that, and then when I finish the wild and scenic, I'll go back and do the non-wild and scenic. We also work with the Park Service and Forest Service and get grants from them to add. And so hopefully, we've been doing this, we got 2,000 reaches, but this is over 7 years of work to get all this data collected and kept up. So it's not, an immediate project, but I'm glad, we have more of a footprint and are getting more of a footprint out west, especially since that's where I live. And, I like to, be able to add stuff around me. Our last guy that I took over for was in North Carolina, so a lot of his rivers are on there. So I'd like to do sort of the same thing out here.
Great. Does it include a link to the USGS gauge for flow info?
It does not. Typically, if it's a whitewater river where that's, yeah. So if it's a whitewater river, we have a link to the American Whitewater website, and they keep the USGS flow level data on their website. So we don't house that data, but we do permit access to it. And they usually have a little bit more detail on that stuff too. So we're at a higher level, and then you work down through to get more detail as you plan your trip.
Great. Looks like that was the next question in the chat box, is the collaboration with American Whitewater, and it looks like you guys have additional data that they don't. So
right, we have water trails and wild scenic in areas that may not be as much interest to whitewater boaters, but we do work with them and we do collaborate with them for the data for rivers where you'll be running, more the above a class 1 or 2 ranking.
Well, great, James. I would put a plug in too. I'd love to see the Western Rivers filled out. I know that's a huge amount of data. So thanks on that, presenting on the very cool tool. We look forward to having more info in that. So James, we're going to move along. Thank you so much.
Thanks.
Okay. Next up, I'd like to welcome Sasha Das from the U.S. Fish and Wildlife Service. Presentations on Ipac, the one-stop shop for environmental reviews. So we'll go ahead and have Sasha's presentation.
Good afternoon. My name is Sasha Das. I work for the U.S. Fish and Wildlife Service in the Western Colorado Field Office, and I work primarily in Ipac, which stands for Information for Planning and Consultation. Ipac is the service's online platform for project planning and environmental review. And today I want to take this time to go over in a little bit more detail what Ipac is, what it has to offer, as well as review one of the new tools available in Ipac called the Consultation Package Builder, also known as the CPB. And for future reference, I am our office's Ipac liaison. So if at any point you're in Ipac and you get stuck on something or have a question, please feel free to reach out and I'll help you work through that. My contact information will be at the end of this presentation, and I'll make sure that that is distributed after the meeting. So I'm going to start with a quick about Ipac and mostly how it came to be. So let's say we have a project proponent, we'll call her Susan. She wants to construct a road. So to begin her project planning process, she'll need information on threatened and endangered species to maybe think about how her project might impact those species, especially if she is part of a federal agency. So before Ipac, she would have to call or email a service field office to get that information. And that biologist would have to manually compile that information and get it back to her. And overall, there was a lot of back and forth between the two on making sure she had the information she needed to plan her project, and on the reverse side, to make sure that we had all of the information we needed on a project to properly review it. And so a lot of time was spent in that back and forth. And so Ipac was developed to hopefully facilitate that exchange of information. So with Ipac, a lot of our information on threatened and endangered species is now available online. So we can kind of reduce the amount of time and back and forth between project proponents and the service on make sure that everyone has the information that they need. So there are several types of information available in Ipac, the first of which are resource lists. So you go into Ipac, you indicate where your project is going to occur, and based on that information and the data that we have put into Ipac, Ipac will let you know what threatened and endangered species will occur in your project area. In addition to listed species, Ipac will also let you know if there are any migratory birds in that area, if there are any wetlands, and if there are any other fish and wildlife facilities in that project area. And one of the nice things about a resource list is if you need some type of formal documentation for your work or for your project planning process, or maybe you are undergoing a formal consultation, these resource lists can be converted to official species lists, so official documentation. The second type of information that is available in Ipac are species protocols. So these include species survey protocols, habitat survey protocols, and some project design guidelines. The third type of information that is available in Ipac are effects determinations. So these are a little bit more detailed analyses about what species are in your area, and given your project type, how your project might impact those species. It'll also give you some information on what conservation measures or steps you can take to either avoid, minimize, or mitigate those impacts. I'm going to kind of run through a quick example, so conceptually you can kind of understand how Ipac works. So in the example I gave earlier, we have Susan who wants to construct a road. She's gone into Ipac, she selects her project area, and then Ipac takes the information that we've put in and queries to see, okay, well, what species then occur in that area? So in this case, we have the singing cactus and the sleeping fish, two of my personal favorites. So now that you've gone in and put your project area in, Ipac has done its work. Now it's generated a resource list or an official species list if you need it, and now you have that documentation. If we do have any survey protocols for those species or their habitat, those will also be available. So you've got those two pieces of information, and really all you need to do for those things is just put in your project area. You may also have to enter some contact information if you want the official species list. The effects determination does require a little bit more data entry and more detail about your actual project type. So in Ipac, there are two ways to do an effects determination to help you come to an effects determination. We have determination keys and in the consultation package builder. And there is also an option where you can use both of these. So a determination key is basically a set of dichotomous questions that will help you come to a determination. So most of us are familiar with this in the context of identifying a plant or a species of some kind. So there'll be a question that says, is the plant green? Yes or no? You'll answer yes and go to the next question. Is the plant taller than 10 inches? Yes or no? And you keep answering these questions until at the end, you know what the plant is. And a determination key works just the same. So at the end of answering all the questions, you'll come to, it will help you come to a determination. In the example that we were talking about, we have the singing cactus that appeared on our resource list, and we have 4 possible outcomes for a determination key. One of those is that the key isn't applicable. So for whatever reason, there's something about our project that that key can address. So that's one option. Another option is a no effect, in which case we've answered the questions and found that our project will not have an effect on the cactus. The third option is a not likely to adversely affect. So those, any impact that we're going to have on that species is minimal or discountable. It's not likely to adversely affect. And in these cases, Ipac will deliver a concurrence letter. It will put your information in our system and let the field office know you've used the D key. So what that means is that if you come to a no effect or not likely to adversely affect determination in Ipac using a D key, you can complete your consultation in Ipac. The field office may still review that information, but you've pretty much completed a lot of your work right there in the system. The last possible outcome is a may affect or likely to adversely affect. And in this case, it means your project may have an impact on the species. And although you can't complete your consultation in Ipac at this point, it will give you a lot of the documentation that you need to complete your consultation with the field office. In our example, I'll say that we were able to determine that our project may affect, but is not likely to adversely affect the singing cactus. And now we have a concurrence letter. So we have a lot of the documentation that we need to submit to the field office. The only other thing is that we had one more species on that list, and we haven't come to a determination for the sleeping fish. So as I mentioned, there is another option to do that in Ipac, and that is called the Consultation Package Builder. The way the Consultation Package Builder works is that it breaks larger activities into small activities. So we're breaking down road construction into smaller and smaller activities until we get to activities that really can't be broken down anymore. And all of this information is put in on the back end of Ipac. You don't really see this, but it will help you really analyze your project. CPB pulls in that information, and then the next thing that it does is that based on those the smallest activities, the CPB will identify possible stressors caused by those small activities. So in this case, we have the use of vehicles off-road. That's leading to the generation of dust, soil compaction, and an increase in invasive species. Then, based on the biological information and the relationships that we've put in on the backside, the Consultation Package Builder will identify how the stressors might affect the species and its resource needs. So in this case, someone on the back end of Ipac has put in information about the sleeping fish. So now we've got an idea about how our project might impact that species. Last thing that the CPB does is that it will recommend conservation measures to avoid and or minimize possible effects. So in this case, we're going back to the use of vehicles off-road, the generation of dust. The CPB will deliver a conservation measure that is generally aimed at breaking that link. And you might see things like reduced vehicle speeds or reduced vehicle weight. And these will help you, hopefully, if you implement them in your project, avoid or minimize possible effects to the species. based on that information, we are able to come to an effects determination for the last species, the sleeping fish. And now we have all of this documentation that we can organize and then submit to our field office. And we are way more likely to have all of the information we need, having gone through that. And the field office is going to have the information they need to properly review our project. So that's conceptually how Ipac and the consultation package builder work. I hope that was helpful. I just want to emphasize that there is a lot of flexibility in Ipac. So we want to make sure that it's a useful tool for our partners. So if there's something that you think we can do better or a way that we might be able to help you with Ipac, please reach out and let us know. If you want to know more, I've put some links to some videos here about how to use Ipac. And then lastly, I have my contact information here. Please feel free to reach out at any point, and I will hopefully be able to help you with any Ipac related issues that you have. Here we are on the Ipac page. I have this Get Started button. I'm going to go ahead and click that. We have a pop-up here about entering a location and logging in, which I will talk about the login option in just a second. So I know roughly where my project is going to take place. So I'll use this function, but you can also upload a shapefile, or you can select a larger area by state or county. I know my project is going to be near Meeker, Colorado. So I'll go ahead and put that in. And in addition to uploading a shapefile or selecting by state and county, I now have a few other options. I can sketch out my project area. I can use a polygon, create a polygon, or I can use a line to draw my project area. So I'm going to do just a little bit of freehand here and draw my project area. And with that, I already have my resource list. So that was relatively painless, hopefully. And now I have a list of all the threatened and endangered species that occur in my project area. In addition to that, I have some information on migratory birds, facilities, and wetlands in the area. You can click on the species icon if you want a little bit more information. And the second piece of information that I mentioned in the presentation was species survey guidelines. So those are available here to download if we have them available. And in this case, we have one available for the yellow-billed cuckoo. So we have our resource list, we have our species survey guidelines, but let's say that I need an official species list. So I'm going to come over here and click the Define Project button. And now it's going to ask me to log in. The reason that Ipac will ask you to create an account and log in, one of those is so that you can save project information so you don't have to complete the review process in one sitting, and you can always refer back to it. The second reason we ask you to create an account and log in is for security purposes so that we can keep your project information secure. So I'm going to go ahead and label or name my project and give it a description. In this case, I'm just entering some text. I would obviously put some more information there if this were not a demo. So now we are at the project home. So this is a tab in Ipac where you can kind of get all of the general overview information for your project. So we have our project location. We can add other people to our project if we want them to be able to access it in Ipac. We have documents here. So this includes our species survey guidelines. If we have an official species list, it will be here too. And we also have a shapefile now for our project location, which is located here. And that's really nice if you didn't have one before. We can also go back to our resource list here. And we have contact information for our local field office. So I still need an official species list, so I'm going to click the Start Review button here. You can also use the button below that, the Request Species List option there. Now I have a pop-up that is kind of taking me through the general steps. So I'm going to hit Continue. And now I have an option to request a species list. You also have an option to skip this if you don't need formal documentation, but want to use the other parts of Ipac. It's going to ask me to put in my contact information, which I've already entered and saved in my profile. You can do that with this button. It'll ask me to put in the type of project that I am working on. So I'll enter that information and request my official species list. Usually this takes a few minutes, but that document will be generated in just a few minutes. So I'm going to move quickly to the next step for my project, which is the consultation package builder. Unfortunately, right now, Colorado doesn't have any functional determination keys in Ipac. We have some in the works, but they're not ready just yet. So I'm not going to demo that today, but I'm happy to do that at a later date. So now we're moving on to this step 3, which is the CPB. And I want to highlight this word optional. A lot of people will come and use Ipac and think that they have to go through this process. But if you have a very simple project and don't need this type of analysis, or you just need an official species list, please do not feel like you have to go through this step. And you can always click out or exit review. I'm going to go ahead and enter the consultation package builder to review my project. And this pop-up is letting you know that the CPB is new. This is a general overview of the CPB, and I highly recommend that you read this before you start. It will give you a lot of information that will help you complete it, but for now I'm going to X out of this. Unfortunately, due to time constraints, I don't have time to take you through an entire project from start to finish, but you can at least see what this interface looks like. I did complete another one before this presentation, and I'm just going to kind of scroll through the document so you can get a good idea of what this assessment looks like once it's completed. So it's quite involved and there's a lot of information that goes into it, but a lot of that information has also been input on the back side of Ipac. So hopefully a lot of this is already there for you. So with that, I will end this demo and try and answer any questions that you might have.
All right, thank you, Sasha. Looks like another great tool and technology for planning purposes. So let's see, it looks like we do have a question. Oh, I think you have answered it. I'm sorry, I'm trying to keep up on the chat. So you guys can see some of the question and answers that are in the chat box. So Sasha, is this the precursor or to pave the way for an official Section 7 consultation on a project? Just kind of trying to get the process in the works?
Yeah, so it will never be able to totally automate every consultation, but especially for consultations that occur often or that are pretty simple, hopefully this can take out a lot of, or help with a lot of that legwork and help project proponents get the information they need upfront and reduce the time that they have to go back and forth with the field office to get the information they need and to make sure that they've submitted everything the field office might need. So it definitely won't replace the gray matter that's needed to complete those consultations, but can hopefully help put all of that information in one place.
Great. Looks like somebody is interested in how big the muskie was that you were holding. Is that a muskie?
Oh gosh, that was it was probably close to maybe 45 inches or so, something like that. That was back from my grad school work.
It's a nice fish. Can the documentation produced by the consultation package builder be considered an official consultation? And maybe you answered that before.
So some documentation is official. So if you request an official species list, that is considered official documentation. So you wouldn't need to go through the field office again to do that. And then you can also get official documentation through a determination key. So determination keys are usually either project specific or species specific. But if you come to a not likely to adversely affect determination, you can get an official concurrence letter for your consultation. I will add the caveat that not every field office has determination keys in place just yet. A lot of offices are still working on those, but there are some that are currently functional in Ipac.
Okay. Well, Sasha, thanks so much. Appreciate the presentation on this new technology and tool for consultation. So thank you.
Yeah, of course. Thanks for having me.
All right. Okay, we're going to, one quick thing before we move on to our last presentation. I wanted everyone to know that we will be creating breakout rooms over the lunch hour. If you hover over your toolbar, you will see the breakout rooms. It's kind of the 4 square boxes. We will be creating those breakout rooms based on topical issues. So you'll see the issues or the topics with each of those, and you can enter and leave as you please to connect with people on those subjects. So wanted to remind you that we will have breakout rooms available for people. Okay, our last presentation for this morning is from Kat Henke with the Southeast Aquatic Resources Partnership. She'll be presenting on expanding the Southeast Aquatic Barrier Prioritization Tool, assessing aquatic fragmentation in the Western United States. And we'll do the presentation and a Q&A.
Good morning, everyone. My name is Kat Henke, and I'm the GIS coordinator for the Southeast Aquatic Resources Partnership. And today I'm going to be sharing with you a little bit about our Southeast Aquatic Barrier Prioritization Tool and how we will be expanding this tool into the Western United States. But before I get started, just a brief background on Sarp. Sarp is one of the fish habitat partnerships under the National Fish Habitat Partnership. And we are also a joint committee under the Southeastern Association of Fish and Wildlife Agencies. So we are under both of those umbrellas. We have a very similar setup to the Western Native Trout Initiative. And we have a steering committee which consists of representatives of each of our member states, as well as other federal, corporate, and NGO partners. And we also have a Southeast Aquatic Habitat Plan that we use to meet our mission to protect, conserve, and restore aquatic resources across political boundaries. And this plan has within it several objectives, one of which is objective number 3, to improve or maintain watershed connectivity. And as many of you probably know, many man-made dams and barriers are very detrimental to aquatic systems. And so we've been working for the past 10 years to develop a connectivity program across our region to build capacity and really build a community of practice to remove dams and replace culverts and other road-related barriers across our region. And we do this through 3 main components in our program. The first is a GIS-based inventory of barriers. And this is really the foundation of our program because we can't prioritize barriers unless we know where they are. And then we have a prioritization framework, which helps us to identify the best barriers to remove based on ecological benefits. And then finally, in the Southeast, we are operating in connectivity teams. And these are teams at the state level, which are composed of multiple different sectors that all work together to build capacity for education and outreach and to streamline permitting, but also to take the results of our prioritization process and implement those projects on the ground. And so about 2 years ago, we received funding from the Fish and Wildlife Service Fish Passage Program Region 4, as well as other funding sources like some state wildlife grant funds and Forest Service and others to build this user-friendly tool online with the help of the Conservation Biology Institute and Astute Spruce. And this tool really helps to visualize our program within a user-friendly framework, and you can go through and look at and learn about each of the components of our program, as well as both summarize our inventory and look at our inventory and prioritize these barriers. And now we have recently received additional funds from the Fish Passage Program of the Fish and Wildlife Service Legacy Regions 2 and 6 to expand this tool out into an additional 10 states. And you can see these 10 states here in this map. And so now I'm going to go through and explain more about our different components of the program. The inventory itself consists of 3 main data sets: dams, road crossings, and waterfalls. And I'm going to explain the dams and the road crossings this time. Our inventory of dams really is a regional database, but it has local relevance and it leads to implementation. And this is because we've worked to supplement the national inventory of dams with local information for over 10 years. The national inventory of dams for this region has about 50,000 dams. However, we have gathered information from dam safety data sets, from local partners on the ground, from dissertation projects, as well as using different GIS methodologies to model dams using hydrography data. And so now we've gone from 50,000 dams to over 147,000 dams. One aspect of our inventory that is unique is this concept of potential social feasibility. And in this case, the potential social feasibility really helps us to get an idea of which projects might be potentially socially feasible on the ground. We wouldn't want to spend time contacting an owner for a dam that's being used. And so we've worked to do this potential social feasibility reconnaissance for over 12,000 dams, working with partners as well as students and interns to look at these dams on aerial maps and get an idea of whether or not they have docks or other surrounding land uses that might indicate they're socially infeasible. And this comes into play when we look at our tool, and I'll explain that in a moment. The next data set we have in our inventory is road crossings. And we have over 2 million road crossings where a road crosses a stream in our region, courtesy of data from the U.S. Geological Survey. However, not all of these road crossings are going to be barriers to aquatic organisms. And so in order to determine which ones are barriers, a biologist or resource manager has to go out to the site and take measurements to determine whether or not it's a barrier. And so we've worked to collect information from our partners on where these sites have been visited to make this determination. And we found that there's over 26,000 of these road crossings that have been assessed for aquatic organism passage using multiple different methodologies or protocols. However, over the past 2 years, we've been working with partners to adopt a protocol created by the North Atlantic Aquatic Connectivity Collaborative, which is a protocol designed to be scientifically robust, but also take less time in the field. And so we've taken this protocol and we've trained 200 people in the Southeast to use it, and they have collected over 5,000 additional data points on aquatic organism passage barriers. All of this information is taken using Survey 123 for ArcGIS in the field and is automatically uploaded into our inventory, which lives on ArcGIS Online. And so all of these data sets on ArcGIS Online are then used for our tool. They're periodically exported off, and then connectivity analyses are completed to then be uploaded into our tool. And so for the Western states, we are now in the data collection phase. And one of the reasons why we wanted to present at this wonderful conference was to identify new potential partners who might have information on fish passage barriers in these new states. Right now, there's over 37,000 dams in the national inventory of dams for our new states here. However, we've been working over the past several months to contact fish biologists and hydrologists and Trout Unlimited and other partners of Forest Service to identify barriers that are not in the national inventory of dams, as well as culverts and road crossings and diversions. And this is what you're looking at here. And just a quick snapshot of how this is really coming together. For example, the state of Utah, in the national inventory, there are 800 dams. However, the state of Utah has an inventory of 5,000 dams that can be also added to that. And the state of Utah has many fish passage barriers inventoried as a part of their Department of Natural Resources that we can then use that incorporates an additional 300 or more barriers to the inventory. So we're hoping to get all these data that we can for these states. And all this information is then summarized in our tool. And so you can see here, this is what our tool looks like, and it will just look the same, but it's expanded out for the rest of the states. And you can look at the states as well as hydrologic units or HUCs or counties and drill down and see what is the density of structures, how many barriers have been assessed, how many road crossings have been assessed, what is the average number of connected miles. And so that's a summarize function in our tool. The next function is the prioritize function. And to discuss that, I'll tell you a little bit what goes on in the back end. Our prioritization really has the main goal of leading to implementation, supporting management decisions, and helping our partners go from an opportunistic approach to a strategic approach to barrier removal. And so for us, we have 3 simple criteria that help us to identify a priority barrier. The barrier would open large amounts of habitat. The removal of the barrier would open access to high quality habitat. And then finally, the social conditions appear favorable. And that gets into that reconnaissance coding I mentioned earlier. And so we have 4 indicators that help us to identify or meet those criteria. And those are the number of miles opened or network length, And then we look at that network, the upstream miles from that structure to the next dam or structure. And we look at that network and look at the sinuosity of that network, the percent natural land cover in the floodplain of that network, and then finally the complexity of that network, number of miles, the number of stream miles, the number of stream size classes gained. And these indicators can be combined into 3 different scenarios. We have network connectivity, which is just the number of miles opened. Network condition, which is the other 3 indicators excluding connectivity. And then finally, a combination of the 2 scenarios. And so very quickly, I'll just share with you a little bit about how it looks to prioritize a dam in the tool, prioritize dams. So you go up here to the top right and click prioritize. And the next window you're taken to allows you to decide whether or not you want to prioritize dams or road-related barriers. And so for this case, I chose dams, and now you come to a window that lets you pick a geographic area. You can pick a state, a county, multiple counties, multiple HUCs. I'm going to choose the state of Florida in this case. I'm not going to go through every step here for the sake of time, but this is what happens if you were to prioritize every dam in Florida, 2,600 dams that map to a stream. And what you come up with is the top dam to remove is the Jim Woodruff Dam. Now, this dam obviously isn't going anywhere just by looking at it. It's definitely got multiple uses and is very, very large. And this just shows how important it is to incorporate that potential social feasibility that I showed earlier. And so for the state of Florida, we were awarded some state wildlife grant funding to perform the feasibility reconnaissance and build up the inventory in Florida. And so now within our filters panel, you can select the dams in Florida that are either possibly feasible or likely feasible based on our feasibility reconnaissance efforts. And in this case, there are 487 dams that are available to prioritize if you're looking at that filter. We also have other filters such as number of miles opened, the number of threatened and endangered species or species of greatest conservation need in a HUC 12, and even land ownership. And one thing that's very important in the West is the concept of beneficial barriers or barriers that block invasive species from moving upstream. And so any dam that has been identified as a beneficial barrier is included in that feasibility and conservation benefit filter and actually not available for prioritization. So we code it within that feasibility indicator. And so now that we've prioritized the 487 dams in Florida, you can then look and toggle to see the results. You can pull the slider and you'll be able to see the top tiers. This is the top 5, 10, 15% of the result. And you can toggle between the different scenarios. But this little dam came up as a high priority for us over and over again in Florida. And it turns out that this dam is a small dam that was not on any inventory prior to us cataloging it. It actually came from a dissertation. And it opens up 33 miles to the main stem Apalachicola River, and it's on a Nature Conservancy easement. And so it turns out that we approached the owner, and the owner is wanting to remove the dam. And so we've gone ahead and done some design and engineering on this site, and it's now fully funded, and we're working on permitting. So hopefully this will be removed next year. And we also have another wonderful example of the tool. This is a dam on the Washita National Forest in Arkansas. And the Forest Service Region 8 provided some funding with American Rivers to identify and inventory dams on Forest Service lands, especially undocumented and small dams. And so this dam kept coming up as a high priority because it opens up several miles to a wild and scenic river right here that runs perpendicular to this tributary. And it turned out that this dam was not serving any purpose. And we worked with the Arkansas Aquatic Connectivity Team and the forest biologist Mitzi Cole in order to remove this dam last year. And so this is a really nice example of how this tool and inventory led to an actual dam removal. And we've also got several culverts that have been removed and are slated for removal from this effort, where our partners have gone out into the field using our protocol, surveyed structures, and then those structures were then prioritized in our tool, and now they're going to be removed, the top priority culverts. And so those are some highlighted wins and successes from our program. And these, again, are our expanded boundaries. And so really what we are hoping for is to work with partners in these states where we may be missing barrier data. We're in the data collection phase now. So if any of you know of any additional barrier data sets that we might be able to incorporate into our work, please email me or call me. My email is here, cat@southeastaquatics.net, and very happy to answer any questions. And thank you all for your attention.
All right. Thank you, Kat.
Thank you.
I want to remind everybody, if anybody has we have a couple minutes left for questions for Kat, if you have any. So sorry, I was trying to soak it all in. So it looked like the Intermountain Rockies region, is that an expanded area for this tool in the works?
Yes, yeah. So what we have completed, and it's always living. So, but in our region, just those 14 states is what we have completed. And then the Rockies and all of those expanded states are the ones we're adding to the tool. So that is part of this project.
How do you gather the information on data? Like you said, the in the Wachita, that was a dam, no purpose. How do you figure that out? What is the data that you gather for that? Is that both, just citizens or land management agencies data?
Yeah, we're trying to come at it from all angles. So we kind of start with like a base data set we have dams and road crossings and culverts are separate right now. So our dams, we start out with the national inventory, and then we have had calls with each state agency, usually the fisheries program, to try and see if they've done any additional reconnaissance on the ground to like identify additional barriers on the ground, or like, for example, Utah and Wyoming have their own state barrier data. And but it also doesn't include some of the national data in other basins they weren't focusing on. So we kind of go from the top down that way and collect existing data. But we do have some states that are interested in potentially going out into the field and collecting it on the ground, or we train volunteers to collect the AOP data in the Southeast with the Trout Unlimited helping with that. So we try to come at it with all angles, but with this expansion project, we're starting with gathering all of the available data from the national level to the state to the watershed groups, any nonprofits or anything that we can.
Okay. Okay, well, Kat, thank you so much for your presentation. That's going to lead us up to the lunch break. So thank you for being with us and presenting the project. Another very useful tool for our streams and rivers. So thank you. Okay, well, folks, that takes us to lunch. Remember that we have breakout rooms by subject and topic area. Let us know if you need more. Please join colleagues in those rooms if you need. Shannon will be back around 1 to pick us up for the monitoring and research block sessions this afternoon. We'll see you in a bit.